In this video, I'll be talking about loss functions in neural network. Loss function is one of the most important concepts in neural network and deep learning. Loss functions helps us to train a neural network model, and it enables the model to learn from data. Loss function measures or calculates the disparity or difference between the predicted output and actual output. The predicted output is the output generated by the model, and the actual output is the output that we expect. The main goal of loss function is to quantify how well the model is performing. The choice of loss function that we will be using depends on the task and the type of data. For different types of tasks and for different types of data, we may need different loss functions. Some common loss functions are given here: mean absolute error, mean squared error, cross entropy, binary cross entropy, KL divergence, and many more. In this video, we'll be trying to look at few of them in detail. Mean absolute error. Mean absolute error is the loss function that calculates the average difference between the prediction and the actual output. This is the equation for mean absolute error. yi hat represents the predicted output and yi represents the actual output. So the difference of these two is calculated, and finally it is divided by the number of data to get the average. Now this is mean squared error. This is almost similar to that of mean absolute error. Only difference is that there is a square on the difference of the two outputs. So mean squared error calculates the average of the squares of the error between the predicted and the actual output. Now coming to one of the most widely used loss function, that is cross entropy. Cross entropy loss function is mainly used for classification problems. That means if there are multiple classes and we need to pick one, then we usually use cross entropy loss function. Cross entropy loss function measures the dissimilarity between the predicted class probabilities with one hot encoded target label. Now a question arises that what is an one hot encoded target label? We'll see it later. This is the general equation for cross entropy, where Px refers to actual class probability and Qx refers to the predicted class probability. So Px is the expected output and Qx is the probability that our model predicts. There's another loss function called binary cross entropy. This is the same as cross entropy, but it is only used for binary classification problems. That means when there are only two classes in a classification problem, we use binary cross entropy. Now we'll be looking at this example to get a clear idea about cross entropy loss function. At first, we need to know what is one hot encoded label. One hot encoded label means that only one of the classes will have a probability of 1 and the rest classes will have a probability of 0. So in this example, the class dog has a probability of 1 while the rest have a probability of 0. So this is the expected output. For example, the input image is an image of a dog. So we are 100% sure, or we are expecting a probability of 1 for the dog class and probability of 0 for the rest. So this is the expected output. And this is the predicted output which is generated by our model. Now this predicted class probabilities is considered to be Qx and the one hot encoded label is Px. Since we now have Px and Qx, we can simply compute the cross entropy loss for this one. And this is how cross entropy loss function is used in classification problems. Thank you.